deal. Let's go ahead and get started. This is the problem we left off with last time. It's also our remote lecture quiz for today. And we had written down all the given information for this problem last time. And this is all we're going to do on this to finish up this problem. Remember, this problem is also up on Canvas, so you can take a look at the full solution. If we have in this problem right here, and feel free to annotate a few things on the stuff we wrote down last time, we know that DC is 4 meters. So that is the only known vertical distance to one of our interior points. Now we also know this 3 meters over here. So we have a 3 meter distance right there and a 4 meter distance right there. So what that means is that we don't actually know the slope of any of our segments. So all the segments have an unknown slope. The problem that we worked completely last time, that one had one segment with a known slope, and we cut through that known slope. That known slope, by cutting through that known slope, it meant we only had an FBD with 3 unknowns. Now, these two FBDs down here that we're showing in this quiz, FBD number 1, let's take a look at the number of unknowns. I will highlight them, and these FBDs are on Canvas. AX, AY, an EX, and an EY. So this one has 4 unknowns. And then this other FBD that we're showing, number 2 over here, it has an AX, an AY, a TCD, and it also has an unknown theta CD in there as well. So this one also has 4 unknowns. Now there is not a single FBD in this whole thing with only 3 unknowns, at least when we're starting off. But the reason that we're looking at these 2 FBDs in particular is because we can utilize the 2 vertical distances that were given. So up here, that 3 meters, that shows up here between our 2 sets of unknowns. That 3 meters is the vertical distance between A and E, which are the 2 points where we have our unknowns. The 4 meters also shows up in those 2 points where all of our unknowns occur. So we're utilizing, even though we don't know a known slope, we're utilizing the known vertical distances, okay? Now, when we have this scenario, it really means that if we have 4 unknowns in one FBD, we cannot solve for this problem with just one FBD or the other. We really need both of those FBDs. I'm going to go ahead, I'll start the polling there. I'll let you all answer, and let's see where we're at. Okay, I got 47% have responded here. Get your responses in. Got 50 participants today. Nice work. Good job getting here. I know that the remote lectures are different, and so nice work sticking it out. Got 80% responded. I'm going to go ahead and end polling. Share the results there. I'm not sure if the 10% and 14% that picked A and B just weren't paying attention or just picked the first thing that came in there. Either way, it doesn't matter, but I want us to understand this this material here, right? So yeah, we need both FBDs. We need FBD number 1 and FBD number 2. So that is the answer for the remote lecture quiz, is we need both of those. Now let's talk about how we can solve this problem. And like, okay, so we need both of those to find the reactions at A. Well, what if we did the sum of the moments about E over here? We would end up with an equation that has AX and AY. So it's got 2 unknowns in it. normally when we sum moments in an FBD, we only have one unknown, but we have two unknowns. So then we move on to our second FBD, FBD number 2 over here. Where could we sum moments about anyone to get another equation with AX and AY? Where could we sum moments about an FBD number 2 and come up with another equation that only has AX and AY? Can go to somebody. Point C. Yes, absolutely right. Moment about point C is equal to 0. And so we take the moment about C, and only unknowns we'll have are AX and AY. Now, from these two FBDs, we will have two equations with two unknowns. Now, we do have to do some substitution, but we can solve for AX and AY. So when you run into a situation, and we'll still take our same approach of find an FBD by looking through all of our potential options. But then, and so we have lots of potential options for these problems, but we can do it intelligently. The intelligent part, I mean, like picking an FBD that cuts through a known slope. Or if we don't have a known slope, in this case, we picked FBDs that had known distances. So this 3 meters was the distance between A and E. That's why the moment about E will only have AX and AY. And then when we sum over here, when we sum moments about point C, because we know the distance from A down to point C is 1 meter, then we know the distance for the moment arms to AX. We also know the distance to moment arms to AY, so we only have an AX and an AY. So when you see this type of problem, recognize that pattern of like using those two vertical distances. You'll see this on the homework, and you can refer to the full solutions that are posted up on Canvas. Any questions?